In this lesson, we're going to learn to calculate power by looking at the relationship between energy, power, time, voltage, and current. And we're going to look at some examples of some exam questions to see how you would calculate these. So we're going to start with a basic definition of what power is. Power is a quantity of energy used over a period of time. So we measure quantity of energy in joules. So it would be the joules per unit time, which is seconds. So we've decided that a joule in 1 second is called a watt. 1 joule consumed over the course of 1 second is 1 watt of power. Now, based on the units, joules for energy, so J is equal to our energy, that's our joule unit, and S is our unit for time. So we can come up with a formula, power is equal to energy over time. So if you're given the number of joules, you're given the number of seconds, you can calculate the power in watts. But we have other ways to calculate power in watts besides this one. The other formulas that we have is we've got that power is equal to IV. Now, I is equal to the current, the electrical current measured in amps, and V is the voltage measured in volts. So that's another way we can calculate power if we know current and we know voltage. Now there's yet another way we can calculate power, and it's kind of an indirect way, and that's because we also have a formula for voltage is equal to current times resistance. So I is current again, we don't need to write that down again, but R is equal to resistance, and that's measured in ohms. So even though this formula doesn't directly have power in it, we can use it to calculate power when we don't know the voltage. Okay, so follow me here. If we have P equals IV, I'll write it up again. P equals IV, but we know that V is equal to IR, then I can just substitute IR for V right here. So what I would get is P is equal to I times voltage is actually equal to IR. So I times IR, therefore P is equal to I squared R. So we can derive that formula, which means we can calculate power even if we don't know voltage. As long as we know current, as long as we know resistance, we can find power. So we now have 3 ways to find power. We've got P equals IV when you've got the current and the voltage. We've got P equals I squared R when you have the current and the resistance. And then don't forget our very definition of power is the quantity of energy used over a period of time. Usually joules per second to make watts. Could also work up with other units, but those units work. All right, so let's take a look at an exam question where we have to do exactly that. All right, so here we have a relatively simple electric circuit. We've got a voltage source, but we're not given the voltage in this particular question. We have an ammeter that's measuring our current right here. We have a switch right here. We've got a voltmeter measuring the volts, and we've got, well, it looks like a light bulb here, number 4, is some sort of electrical device that's being powered by this circuit. So if the ammeter reads 4.15 amps, so that ammeter is reading that, and the resistance of the device labeled 4 is 2.88 ohms, then the power rating of the device labeled 4 is blank watts. So what we are given here is we are given current and we are given resistance, but we are not given voltage, which means that the formulas we have to choose from, we'll just write them down again. We've got power is equal to the energy divided by the time. Well, we don't have energy and we don't have time, so we're not going to use that. We've got power is equal to current times voltage. We have the current, but we don't have the voltage. But here's the formula that we're probably going to end up using. P is equal to I squared R, where we just have the current and we have the resistance. So that would be equal to 4.15 amps. And then we square that. And then we multiply that by 2.88 ohms. So when we do that, 4.15 squared times by 2.88, we end up with the answer of 49.6008. And our unit for that is going to be watts. The unit for power is watts when we're using the appropriate units of amps and ohms. And we can write out our answer here. It says 3-digit answer. So we wanted 3 digits, which makes sense for our significant digits because we've got 3 digits in this number, we've got 3 digits in this one, so it should have 3 significant digits. So I would just write this as 49.6 watts.